So, good evening and welcome to this Devops Playground. This is a playground about hands-on with Terraform Cloud and GitHub Actions. So we're going to have a look at building a very simple CI/CD pipeline just with out-of-the-box tools provided to us by Terraform Cloud and GitHub. This is just going to be a proof of concept, but it's going to be very powerful in just showing us what can be done with these tools. Right, so DevOps Playgrounds. It says here, inspiring tech enthusiasts to explore new technology during hands-on monthly events. So this is definitely meant to be a hands-on session. I hope you all brought your laptops. You're meant to work alongside me in the second to thirds of today's presentation. The instructions should be easy enough to follow on your own, but we are going to walk through them together as well. So fear not, but definitely meant to be hands-on here. All right, so who am I? My name is Jeff Hemmen. You've got my email address here. Do be in touch if you have any questions or feedback. For purposes of two-factor authentication, I am wearing the same shirt. I'm a delivery consultant here at ECS Digital. And I'm HashiCorp certified in many things. I'm a Terraform advanced user. I'm a Terraform trainer. Actually, we offer training here. If you're interested, again, do get in touch. And just a bit about myself. I play the trumpet and the French horn, and I'm a grade 5 shower singer. All right. Login details. You've got the Wi-Fi password here, and if you are attending this in person, this won't be possible if you're doing this at home later on. But if you're here tonight, you can get the AWS credentials by following this little shortened link. Quick hands up, has everyone managed to connect to the Wi-Fi successfully? Yeah. Okay. Fantastic. My colleagues will come and help you if there are any more issues. All right, so let's just jump into it. What is Terraform? Another quick hands up. Who here has never touched Terraform before? Okay. Who has played with Terraform but only in small internal or personal projects, never in production? Okay, cool. Well, I hope to give you a good idea of what Terraform is, what it can be used for, and also what Terraform Cloud is. So let's just jump into it. So what is Terraform? Terraform, as most of you already know, is an infrastructure as code tool. It's created by HashiCorp. It is the most popular infrastructure as code tool currently out there. So we can use it to describe the infrastructure we want. For example, our cloud infrastructure in like tonight, AWS Cloud. We can describe the resources we want. We want this and this instance. We want this and this database. We want this and this firewall. And we want this to link to that and the other. Terraform has more than 150 providers. Think of a provider like an API language pack. If you want to provision infrastructure in AWS, you talk to the AWS API, so you need the AWS provider. If you have an on-premise Cisco firewall, you can configure that with Terraform. You just need to know how to talk to its API, so there will be a provider for that API. With Terraform, you can literally manage anything with an API. Most commonly, these will be your cloud infrastructure providers. The public ones, AWS, Azure, GCP, and pretty much all of them, IBM Cloud, DigitalOcean. You can also do configuration management with Terraform, configure firewalls, configure your Docker setup, configure HashiCorp Vault. And a fun fact, in the US, there is even a Domino's pizza provider. So you can literally provision yourself a pizza using Terraform. Here's an excerpt from the documentation, which I found brilliant. Terraform Destroy is implemented on the client side by consuming the pizza. Right, so the Terraform Architecture. Terraform is a single binary written in the Go language, and it runs on your local machine. I commonly run Terraform from my own laptop, or it runs from a CI/CD server, so you can set up your own CI/CD server and get the binary on there, and then just run it depending on the logic that you're implementing. That's really all there is to it. You'll need your configuration, your Terraform files, they end in .tf. They're written in HashiCorp configuration language. We don't need to worry about that tonight. I have prepared a project for you, so we don't need to worry about writing proper Terraform, just about how it can fit into the bigger picture. And then Terraform of it goes and makes standard API calls, for example, to the AWS API. Now, what about Terraform Cloud? Terraform Cloud is mostly the same, works mostly the same as open source Terraform, but it runs not on your local machine or on your CI/CD server, but it runs on Terraform Cloud. You find Terraform Cloud, and we will very soon do this under app.terraform.io. Terraform Cloud integrates with source code management tools such as GitHub, GitLab, Bitbucket, and it eases that management burden, the age-old chicken and egg problem. How do I provision the infrastructure that I use to provision my infrastructure? Right. What we will do shortly is we will all run the same Terraform project and provision resources, but we won't step on each other's feet. And this is how this is possible, using Terraform State. Now, Terraform keeps track of the infrastructure that it has created. Terraform creates an instance in the cloud. It knows about it. It only knows about it because it puts it in its state. So if we have the same code deployed with two different states, we'll see how we'll do that later, literally next slide, then this will result in two completely independent sets of infrastructure. So we'll each provision run the same code basically, but we'll all have our own set of infrastructure. This doesn't work, however, if the resources need to be unique for obvious reasons. So what we've done here is we've assigned each of you an animal. Again, you should have one on your paper slip. This is not strictly needed for instances because they get a unique identifier at creation time, so they can have the same name, that's not a problem. But it is strictly needed for DNS records. If you think about stuff like zebra.mydomain.com, that can only exist once. So how do we go about it? So this is about Terraform Cloud and a bit about its internal structure. So in GitHub, which, quick show of hands, who is not familiar with GitHub? All right, so GitHub is really just a place where your Git repositories can live so that your team can work together. Often you have a namespace which is just your username. In my case, that's Jeff Hemmen, but you can also create organizations. For example, your organization X, and then you have a repository in there. Terraform Cloud, very similar, except that there is no default namespace, which is your user. Everything is an organization. When you create a Terraform Cloud account, it prompts you to create an organization. That might sound dramatic, but if you find any unique identifier that's not taken, for example, your username, that could be your organization. Right, and then what we will do is we will push code. We will push code to our repository on GitHub, and we will have a workspace in Terraform Cloud linked to that repository. That workspace will watch for changes. The Terraform code lives on here, and it will then run Terraform and provision our cloud resources. Now, each workspace has its own state. So because every one of us will probably work in a different organization, we'll probably all create our own organization, and then within that organization, our own workspace. We'll all have our own Terraform state, which explains how we can all run the same code without stepping on each other's toes. All clear so far? Can we have questions at the very end, actually? Yeah, shouldn't have asked if everything was clear. Right, branching strategy. Quick word on branching strategy. What we will have a production environment. So we will deploy a little app, and we'll have the production environment, which is also the live environment, the one that customers can see is the way I often think of it. And this will live on the master branch. So the code for this will live on the master branch in GitHub. We'll have our staging environment, which you can think of as the kind of pre-flight check environment. So when we think it's ready to be released to the customer, we release it to staging, and then we put our QA guys on it to say, is this ready to go? And if they're happy, then we can take that very code that has already existed on the environment that we have tested and merge that into master, and we'll do the exact same thing with dev environments. So it's typically you can have many dev environments that can then feed into staging. There are many strategies. This is just an example, simple one that I've come up with. And the thing that we're going to focus on here are shall I unplug, plug in again?
Overheated.
It overheated? Oh. Should we give it a beer? Right. Roll with the punches. Who here does not have a GitHub account on public GitHub?
So maybe my question time.
Yes, maybe question time.
Yes. It's quite important for me. So Terraform Cloud, is it free, paid, or there's some free tier?
There's a free tier.
So if I work for a company and we deploy something using Terraform CLI at the moment, and the stake is on AWS is free, can we just sign up and have it for free at the moment?
Absolutely, yes. So it's difficult to answer this. So the question, for those who didn't hear, is about the pricing of Terraform, open source, and cloud, and enterprise. It's difficult to answer this generally because HashiCorp are actually quite generous in what they make available for free. They continuously develop new features, and then they continuously add more to the free offerings. So about half a year ago, you couldn't deploy stuff from Terraform Cloud. You could only have your state there. But I'm going to say roughly 6 months ago, they changed that, and you can actually deploy, have your Terraform run on Terraform Cloud for free as well. There is also a really good guide in the documentation about how to migrate your state. Terraform does this smartly. So if you're already running Terraform, open source Terraform CLI on your own laptop or in your on your own CI/CD server, and you want to migrate to Terraform Cloud, there is a way where Terraform automatically migrates the state over, because as we've seen, state is really important. If your state gets lost, you are in deep trouble with Terraform, because it basically means Terraform can't manage the state. So yes, you can migrate over, and yes, there is a free tier. It is limited, especially in terms of parallel execution. I think on a free tier you have one Terraform run at the same time. So if your team has more than half a dozen people, you might run into bottlenecks there. Happy?
Yes, can I have more questions?
Anyone else have any questions? One more question.
I will confuse everybody.
Oh, hold on. We wanted the, is this box set up? Test. Test. I don't think it is. Right, I'll repeat your question.
Okay, so Terraform Cloud will work as my continuous deployment platform. So why do we need GitHub Actions for integration?
Terraform Cloud offers this will make sense after we've run through it all, so you'll see what it's all about. But what we're demonstrating here is just a few things you can do, but for many other things you'll need specialized tools for this. So we'll see what Terraform Cloud can do, and then we see what it can't do, what we do with GitHub Actions, and then when we come to credentials, we'll see that there is actually it's not an optimal solution. So in a real scenario, we'd probably also want to have some software solution to manage credentials better.
Thank you.
You guys realize it's mirrored? Okay, cool. Cool. Yeah.
We don't ever have to test it.
They're highly available, but the failover time isn't.
There's no provider.
We should write one. It just sends a Slack message to the ops guys.
No, I think it's the win. What's this one? It's Jack.
Is it? Is it actually the icon on my microphone? Wow, I thought it was something upstairs. Shall I move over there? Will that help? No, we'll switch it off. Next, I'll overheat. For those that make it to the end, there will be pizza and beer. Nice. Fantastic. So, this is our branching strategy. Quick recap. We will have changes, as in if we want to bring a change to application, we will put that in one of the dev branches, and then we will merge that into staging, where it can be manually reviewed. And then from staging, we can then merge it into master, where it will then be available to our end customers. This is very common in software development, but it is not as widely adopted as it should in infrastructure. And what we're doing here, even though the actual changes we're doing still look a lot like application changes, what we're actually, the methodology that we're using is to bring this same methodology to infrastructure, since we're using infrastructure as code. Now, I said the green branch is for manual testing. And what we want to do here is we want to add automated tests to these merge requests or pull requests. Now, what we have here is when we merge from, this is what we'll do in the hands-on session, when we merge from dev to staging, we will have a Terraform Cloud speculative plan. We'll see what that is when we get to the hands-on session. And then when we merge from staging to production, we will have a Terraform Cloud speculative plan, but we will also have a GitHub action, which is a staging health check. So before we put any changes live, we have an automated check that just very superficially sees if staging is even reachable. And the result of that is that we can deploy with a high level of confidence. Now, a quick word about what we're going to deploy. I'll give you a minute for this to sink in, and then I'll walk you through it. I made the arrows myself. So, first, the purple stuff. Terraform will provision 3 resources. It'll provision a security group, which is basically a firewall in the cloud. It'll provision an EC2 instance, which is basically a virtual machine, computer in the cloud. And it will set up a Route 53 record. Route 53 is basically DNS. Then our instance has a little bit of user data. So when it starts, it will pull an image from the Docker Hub and basically host that little Docker application. And then what our end users can do is they can check the DNS record, and then when they have the IP address of our machine, they can then talk to the machine. Let's begin. All right, so has everyone, there might be a bit of flaking here. No, we're good, we're good. Has everyone found this repository on GitHub? Again, I'm hoping that it'll work fine. but it is possible that there will be issues due to GitHub status. Can people at the back read this, or shall I make it bigger? Bigger, right. Right. You should see this repository. Has anyone managed to find this repository? Yeah, fantastic. If not, please raise your hand, and one of my lovely colleagues will be by to help you. Cool. Right. Then we have a section about creating and connecting prerequisite accounts. So step 1, have a GitHub account. I think that everyone, or almost everyone, already had a GitHub account. Step 2, have a Terraform Cloud account. If you don't, let's make this a bit bigger. Very nice. Yes. If you don't already have a Terraform Cloud account, you can just navigate to app.terraform.io and click on create a new account or register. It is very straightforward. I have tested this on non-technical people. We should all be fine. Who does not yet have a Terraform Cloud account? Show of hands. Cool. That's not too many people. Give you a few minutes. Right, moving on to step 3. If I'm going too fast, if anyone is seriously behind, do let me know. Connect Terraform Cloud to your GitHub account. So here we need to establish the link between Terraform Cloud, the hosted service, and github.com, the hosted service. So we're basically giving Terraform Cloud access to our repositories on GitHub. Now, the instructions, again, should get you there. Do raise your hand if you have any issues with them. I'm already connected, so I can't really demonstrate this part. The what? Oh, yeah. Yes. So, as I said before, it'll ask you to create an organization. That might sound a bit dramatic, but it can be anything. It could just be your own username. They are free, really, but it's basically a name spacing strategy.
My GitHub all repositories or some repositories?
That's up to you. Yes, it's easier if you say all repositories, but if you are not happy to grant Terraform Cloud access to all of your GitHub repos, you can come back to the step after you have forked the sample Terraform project repo and then grant Terraform Cloud access. So it is easier, unless you have really good reasons not to do this, it is easier to just grant Terraform Cloud access to all of your GitHub repos. Quick hands up, who is still working on one of the prerequisite steps? Cool. So everyone's managed to connect Terraform to GitHub, yes? Fantastic. Then let's move on to the section setting up and configuring our pipeline. So in the first instance, we will set up our pipeline. We'll set up our production, staging environments, and master staging and dev branches. We'll configure Terraform Cloud, and we will set up our GitHub action. And then when that's done, we will make a few merge requests, pull requests, and then we will see them fail or succeed depending on what we've done. So, step 1, clone provided repository. Again, this step I can't really do with. Actually, now I should be able to do this with you. This link is the repository that you should already be on. And let me quickly zoom out for a second. All you need to do is hit fork up here in the corner. Now, off again. The fact that 30 people have forked it means that, well, 30 people have forked it. So that's fantastic. Very nice. Fantastic. So now I have forked this repository, which means that I have my own personal copy. So rather than this being hosted under Devops Playground, which is invisibly written here, it's under my own personal namespace. That is, however, just to make the initial setup easier. Right. Now, the next bit we'll do in Terraform Cloud. We'll create a new workspace. So we will go to Terraform Cloud. You select the workspace that you have created. I have 3. Again, they're free. They don't mean much. It's just a namespacing strategy. So I'm just going to choose this one. And we'll click New Workspace. Now, you might already be on this page from when you connected Terraform Cloud to GitHub. But what we need to do is we select our version control provider. You should have GitHub in this box here if you've set it up. And then it'll show you a list of repositories. If you are members of other GitHub organizations, you need to choose the correct organization or GitHub user namespace here. So for me, that is probably, all right. For me, that is hands-on with Terraform Cloud -1. For you, it's probably hands-on with Terraform Cloud. Now, after we've selected this, we want to change the name of the workspace to 2048-prod. And then click Create Workspace. Oh, thank you. Right, after we create workspace, it says waiting for configuration. This is Terraform Cloud basically cloning the repository from GitHub, getting the Terraform project code. Once that's done, it should take a few seconds. It says configuration uploaded successfully. And then we can configure variables here. Come again? That's the name of the workspace, yeah. Yeah, but it'll make most sense. Yeah, you can later call it anything, but for now, call it 204.8prod because we're going to use this later. Oh, that was loud. Right. Variables. Anyone much behind? That's cool. All right. So under variables, there's 2 types of variables. We won't go into technical details, but there's Terraform variables and there's environment variables. Now what we need to do, we need to set 2 Terraform variables and 2 environment variables for this to be able to work. Now, one of them is called animal, and the value is whichever animal you have on your slip of paper. That is literally, again, just so we don't step on each other's toes. So I am iguana. Don't need a description. Please be very sure that you don't have any trailing or leading spaces in here, or you will have hard to fix errors down the line. So this is just the word animal, no space, just the word iguana, or whatever your animal is, with no spaces. The second variable we're going to set is just env, short for environment, and this is prod, short for production, again, the live environment, if you will. Good. The next step is where the AWS credentials come in. So if you follow the short link that I have, that we have put on this piece of paper, you should see these AWS credentials. Now, the bit left of the equal sign is the name of the variable, and the bit to the right is its value. So you need to copy these one by one, and then add them as environment variables. So again, it's probably best if we have questions at the end, but HCL basically is what you need to select if your variable isn't just a string or a number. So if your variable is a list, or it's a map or dictionary, or something like that, it'll have special symbols like square brackets or squiggly brackets, and those will then need to be interpreted as such. So they will need to be interpreted as HCL. So that's what HCL does.
It doesn't go to that link.
Come again?
It doesn't go.
The second to last letter, by the way, is an uppercase I for India. It's not a lowercase Lima. Does anyone else have issues finding the AWS credentials? Cool, fantastic. All right. So yeah, you put those as Terraform variables in your repo. So the key, again, is... oh, sorry. It's an environment variable. So the key is the name of the variable, for example, AWS access key ID, and the value is whatever it says in that text file. Please also do mark them as sensitive. That means that they will actually be stored in HashiCorp's vault behind the scenes, and they can't be read except when Terraform is actually being run. So we'll add AWS access key ID and AWS secret access key, mark them as sensitive, and save variable. The next bit we do, again, this is all in, if you fall behind, you can just follow the instructions. So what we've done, new workspace, GitHub provider, we name it 2048 prod, create workspace. We have set these two variables. We have set these two variables. And now we go to settings and in general, and we set apply method to auto apply. So settings, general, and then apply method we set to auto apply, and then we say save settings here. All right, next up, step 4. Is anyone really behind? Fantastic. Right, in the top right corner, click Q plan, and then as reason we put initial deployment, and then again we click Q plan. So here Q plan, which basically tells Terraform Cloud to put this next on the queue of things to run. It'll run immediately because there is no queue at the moment. Initial deployment and queue plan. And now, unless there is something seriously wrong, this should do a Terraform plan. I have explained a lot about what Terraform plan and Terraform run does in the README, so do feel free to actually read that. I've put a lot of effort into it. And then here we can see Terraform is planning to add free resources. Remember, we've outlined them in the presentation just before. So that is, we can actually see it here. If we make it big again, the free resources it wants to create are the instance, the Route 53 record, the DNS record, and the security group, the firewall. And then after, scrolling is a bit funny on this big screen, after the plan is finished, the apply will start running automatically because we have set this to auto apply, which you may not want to do, but I think it's neat. Again, I'd like to have questions at the end, so do feel free to stay for a slice of pizza, and I'm happy to discuss it if we don't have time during the Q&A session. Is that okay? Fantastic. So once this is done, at the end of the apply phase, Terraform prints any outputs defined in our project. Here we have one output called URL, which is the URL under which we can reach our web app. So if I click on apply finished, it collapses automatically. Then at the bottom, I find URL here. Now we can copy and paste this to a new tab. Has anyone done this already? Quick show of hands. Who?
Mine is not working yet. It works.
Fantastic. It's always possible that it takes up to 2 minutes for the DNS record to propagate and for the things to work. So who has not yet managed to deploy this? So the URL, once you've run, I'll make this a bit smaller just for better visibility. Once you have run, once you've queued your plan and your plan is run, then at the end of the apply, you should be able to click on apply finished, and then it expands. And at the end of that output, you should have a section in green. Fantastic. All right, let's move on. Next, we will create a staging branch in GitHub. Now, this should be very quick and painless. So, in this repo, we find this button that says Branch Master. We click it. We see a list of all branches. Currently, we only have master. We enter staging into this box, and then we should be able to click on Create Branch Staging from Master here. Now we have a staging branch, which has exactly the same code on it as the master branch for the time being. Now we have a staging branch. You click on this bit that says branch master, and then it only shows master in the list. So you enter staging into the text box, and then you should have an option at the bottom that says create branch staging from master. If you do miss any of the instructions, they're all really well documented in the README, which is just this repository, the README of this repository. Done. Right. Next up, we will create our Terraform Cloud workspace for staging. This is very similar to what we've just done for prod, but there are 2 extra steps which I've highlighted with warning emojis. So what we'll do here is we will go back to workspaces. We will click new workspace again. Same thing, we select GitHub, we select our repository. This time, we change the name to 2048 staging. And before we hit create workspace, we go to advanced options, and we tell it VCS branch, version control system branch, should be staging, which means that this Terraform workspace tracks the staging branch, not the default branch as the other one did. Again, the name 204.8 staging, VCS branch staging. We hit create workspace. And then says configuration uploaded successfully. It was a bit faster this time. Again, like before, we configured the variables. They will be the same as before, except that env will this time be staging rather than prod. Add variable animal, which is iguana for me. Env, which is staging for me. Putting in my AWS credentials. Does anyone not know what AWS credentials are or are used for? Don't need to explain AWS credentials? Fantastic. So Terraform will make API calls, as mentioned before. So Terraform will actually talk to the AWS API. All Terraform does, it takes instructions, sends them off through the internet. Jeff Bezos opens his laptop and says, oh, that guy wants a new firewall rule, I'll put that in. Now, Jeff Bezos obviously needs to know who this request came from, and that is where our credentials come in. So there's a whole bit about how these are managed and policies and users in AWS, which is outside the scope of this. But basically, the credentials that I've provided you tell AWS these people are authorized to provision a firewall, a virtual machine, and a DNS record on ECS Digital's cloud account, which basically means you create them in our account, and the credentials help the API endpoint know who made the request. They're basically a fancy username and password, if you will. Cool.
But they have to have permissions to do that, right?
What do you mean?
Like you've got the key and the secret, and they have to, once they log into the AWS device, they still have to have the access to the...
Absolutely, yeah. I've created policies for all of this. Yeah, I've taken care of all of that because it's... Yeah. Right, so same here. After we set the variables, we go to settings general, and we set our apply method to auto-apply. Scroll all the way down, click save settings. And I'm going just straight through this because we've done it before. Qplan, we set this to initial deployment. Let's make this a bit bigger again. Oh, that's a bit too big. And we hit Qplan. And our Terraform Cloud will go ahead and run exactly the same code, but with a different variable for environment. So Terraform will actually tag the things as staging rather than as production, and it will provision basically the exact same thing again, but we will call it staging environment. Again, because we have two workspaces now, we have got the production workspace, which we see is already applied, and the staging workspace, which is still planning because we've literally just done it. These will have different Terraform states, so they can run the same code as they are without interfering with each other. Again, there's this kind of questions, if you could have that towards the end. Richie? We can see that from planning, my run status has changed to applying. So the plan was successful, and now Terraform is actually making the API calls to provision the resources. So for me, this is now applied. I can click on it. I can click on the run. And same as before, I should have the output, but this time the URL is slightly different. Instead of prod.youranimal.february.london.devopsplayground.com port 2048, it's staging. That's just a way for us to differentiate these things. But please do make a note of this URL because you will need it in the next couple of steps. So please make sure, if you just open this in a new tab, that should be helpful in recalling it when we need in a minute. Who has not yet managed to provision their staging environment? All right, no worries. Right, I think it's time we move on. If your Terraform is running, then you can just leave it running while we do the next step and a half. So next, we're just going to create a dev branch. So already we've done this before. Very quick. We just click on the button that tells us our current branch. We enter the name of the new branch, and we say create branch dev from either from staging or from production. They are the same at the moment because we haven't changed anything there yet. And then we should have 3 branches in total: master, dev, and staging. Right, that was step 9. On to step 10. This is a bit exciting. This was new for me when I set this up. GitHub Actions also relatively new. I want to say, are they a year old now? A year, 2 years, something like that. So what we'll do is we will switch to the master branch, where we want to create a file in the master branch. And the path of this file is here, so we can copy this already. GitHub workflows prod.pr.yaml. And the content of that file is this. So this is YAML, and it basically tells GitHub the name of this action is prod.pr. Just chosen that name because it tells us what it is whenever a PR, a pull request, hits production. Now we tell GitHub this on, so when is this triggered? Pull request, whenever there's a pull request, but for which branches, and then a list of branches that just contains master. So GitHub now knows to trigger this whenever there's a pull request that hits master. And now we tell it which jobs to run. So there's the job staging health check, which again for us is clear what it does. It health checks the staging environment. We tell it runs on Ubuntu latest, so it actually just runs on a Docker container, I believe. And then we give it the steps. So here's a human description, health check, the staging endpoint. And let me make this even a bit bigger. For the people at the back, let's scroll up. Run, basically execute command on that container, curl, and then the URL to our staging environment. Remember, we made a note of that. It is staging.ouranimal.all this stuff. So you'll want to substitute that. All right. I'm going to go ahead and do this. Again, you can follow the step-by-step instructions if you fall behind. First, we switch to the master branch. Then we say create new file. The name of the file, we can paste it. So there is a directory, a hidden directory, which is why it starts with a dot. That's not a typo. A hidden directory in the root of the repository called .github. In there we have a directory called workflows. And in there we have a bunch of files. In this case, one file called prod.pr.yaml. Now, we put the content of our file in here. And we replace staging URL. Make sure to also replace the angular brackets when you do this. We replace staging URL with the actual URL of our health check. I'm going to leave that up for a minute just to make sure we all get the format right. And also, here's an interesting fact. For security reasons, as a security measure, any pull requests that come from forked repos will not automatically be run or even automatically be tested by Terraform Cloud to make sure that there is no leakage of confidential or sensitive information or no malicious code execution. But don't test it, please. Right, who is still before this step? Who has not yet gotten to this step and saved this file? All right, cool. Then let's move on. Create new file. We commit this directly to the master branch. That is obviously not a recommended strategy, but while we're setting up our pipeline, that is absolutely fine. There are additional settings to protect our repository, our branches, but we won't go into too much detail now. But I do invite you to read the README again. So we should now have our pipeline set up, and we should be able to move on to the next section, which is testing our deployment pipeline by creating a few pull requests. Is anyone quite behind and would like some help, or would like me to wait a minute before we move into the last section of this playground? Fantastic. So the first pull request we're going to raise will have a syntax error in it. So I'm going to read out what I've written here because it's quite worth it. In this section, we will introduce a syntax error into our Terraform project on the dev branch, and we will try to merge this into staging via a so-called pull request. Terraform Cloud should automatically check if this new code could be deployed to the staging environment and let GitHub know if there is an issue. Since we're introducing a syntax error, we expect that there is an issue, and this pull request should then be unable to merge or should be vetoed anyway. There should be a warning at the very least. How GitHub responds to this can be configured. So what we'll do is in GitHub we open the forked repo and we go to the dev branch. We edit the file securitygroups.tf, that's the firewall one, and then we click the pencil icon, which will allow us to edit this file, and we will add a line that says kill all humans, bracket open, bracket closed. Now this directive is not yet supported in Terraform version 0.12, and therefore it should raise an error in the Terraform plan stage. So let's try this. I'll zoom out a bit for ease navigation. Step 1, we make sure we're on the dev branch. Very good. And then we find a file called securitygroups.tf, and we click on that, and that will show us the contents of this file. And then there's a little pencil icon over there on the right, which we can click to edit this file. And then at the very bottom, we say kill all humans, bracket open and bracket closed. And then we commit this directly to the dev branch. Once we've done this, now our three branches, master, staging, and dev, are no longer identical because there is new code in the dev branch. So when we go on pull requests, sometimes there's an automatic prompt for us to create a pull request, sometimes there isn't. So we'll click the green pull request button. And here, please be careful. As base repository, we do not want the one that says Devops Playground / hands-on with Terraform Cloud. we want it to be our own one. So, hey, I can see all your, very nice. So you select your own one, please. And then once you do that, your UI should simplify so that you only have 2 of these buttons. And then we say we want to merge into staging, so we set base to staging. And we set compare to dev, which means that we want to merge our changes from the dev branch into the staging branch. And GitHub even tells us here with the green section what has been added to this. So when we have this, we then click Create Pull Request. And then if necessary, create pull request again. You can put descriptions and names there if you want, but that's not really the focus of this playground. Now, the interesting section, the one that might be new to you, even if you've used GitHub before, is this orange bit, which for a second said checking ability to merge or something to that effect, and now tells us all checks have failed. And then let me scroll up and zoom in a tiny bit. Then it tells us there is this check Atlas / and then our Terraform Cloud organization and then our Terraform Cloud Workspace. Atlas, by the way, is the old legacy name of Terraform Cloud, in case you're wondering. So that one has failed. We can click on details, which will then, that is a link to Terraform Cloud. However, you won't be able to find this page if you start off on Terraform Cloud. This is known as a speculative plan, which is one where Terraform just sees if this could work. And this is not findable if you go to the runs list, which makes sense because otherwise with every pull request, you'd have a lot of these plans and you'd lose the kind of overview of what's happened. So here in my run list, I can only see my initial deployment. I can't see my speculative plan. This is sometimes confusing to people when they start using Terraform Cloud, but it's a design decision and one that I think is very valid. So here we can see plan errored. Terraform gives us a reason, and as we suspected, line 34, kill all humans. There is something wrong with that directive. Has everyone gotten to this stage yet? Who is not yet here? Fantastic. I think it's time we move on to the second pull request that we'll try to do. Is my microphone still working? Fantastic. The next one is a runtime error. So this will actually sail through the static code check. So the code will make sense to Terraform, and Terraform will deploy it. But there is an issue. Basically, we were putting a firewall rule in place that prevents us from actually accessing the application, and therefore the GitHub action that we've put in place will veto this merge when we get to it. Terraform Cloud will automatically check this. However, this is fine. However, the GitHub action we have set up will be able to detect that the staging environment is not reachable, and therefore will veto merging into the master branch later. So what do? We go to the dev branch again. We edit securitygroups.tf. We remove this line, kill all humans. That was clearly not the way to go about that. And then in the second ingress block, please make sure it's the second one, we change this number. I've just added a 0. And then we commit changes and we do a pull request like before. So first off, we make sure we're on the dev branch. Dev. Then we go to the same file, securitygroups.tf, and we find the little pencil icon again. We've done this before. First step is we're removing that line, kill all humans, gone. And then in the second ingress block, which is the middle one here, this 2048, we're changing it to anything else. So I'm just adding a 0 here. I'm committing these changes. And I should now be able to go to the same pull request. But because we have updated code, Terraform Cloud will run on this again. So we see some checks haven't completed yet. This is because Terraform Cloud has seen we have changed code in the dev branch. We have an open pull request from dev to staging. So Terraform Cloud is running this speculative plan on the staging environment. We can hit details. And then we can see basically that it has done the plan stage. Plan finished, and it even gives us the warning here. This is a speculative plan. You can't see this. You can't find this from within Terraform Cloud, and there is no apply to be done here. But as expected, Terraform now says, well, actually I can deploy this. I have no issue with this because Terraform doesn't know the firewall rule doesn't work. So we can say merge pull request and confirm merge. Very good. Now that we've confirmed the merge request, if we go to our workspaces in Terraform Cloud, we should be able to see automatically Terraform has seen there is now not just a pull request, but there is actually a merged pull request. There's actually new code in our staging branch. So Terraform Cloud says, well, because we've hit auto apply, I'm going to plan and then execute this automatically. So the fact that we've committed this code and merged it is enough to get this out to our environment. At no point do we actually have to log into Terraform Cloud to trigger a deployment if we set it up this way. This is really, really useful if you want tight correspondence between our code and our environments, which is crucial if we want high levels of confidence in our code and our infrastructure with infrastructure as code. Now we see that this has been applied. Fantastic. Is anyone behind? Do we want me to wait? Should we go to the next step? There's a hand up there. Everyone else happy to move on? Yeah, we want that pizza, don't we? So what we do now is we will now open a pull request, if I remember my own instructions well. And again, please make sure you don't select a base repository that's different from your own. Please do select your own. And then this should simplify. You shouldn't have the long buttons. You should only have the short buttons. Now what we want to do is we want to merge from staging into master. So as I said, there should be or could often be a manual review. But in this case, let's say we forgot because the site is actually at the moment unreachable. If I go to this URL, if I refresh now, it will just time out. We can see it's loading and loading and loading. So this is actually not reachable. So if I create this pull request from staging to master, our GitHub action should come into play. And let's refresh this. Yes. So this last one here is the staging check again. Let's ignore that for now. According to the documentation, that shouldn't be here. So we have our Terraform speculative plan. So Terraform will again see, could I run this? And the answer is yes. Terraform is absolutely able to update our firewall rules to something that won't work later. So this should resolve to green. There we are. However, GitHub will now run its GitHub action. So it'll spin up a container and it'll say curl this, basically what we're doing here in my tab in the top right, that's still running. And it'll say, try and curl this. Now, it says failing after 32 seconds. As you can probably guess, that's because there's a 30-second timeout. You can tweak all of that if you want. We can click details, and let's zoom out a bit. We can then see here health check, and then loading, and then we can see the actual curl command, and it doesn't get any response, and at the end it times out. I'll let you explore that in your own time, but basically that is very good. That is that. So let's have a look at what is next. Runtime error, we have that. Click merge pull request. Click the green create pull request button. Observe the section about checks. Yeah, so we found our 2 or 3 checks. And then GitHub should now, after all checks are finished, display the message, some checks were not successful. And then we can explore this. And then when we're done exploring, click the gray close pull request button at the bottom of the page. So let's do that. Pull requests. At the bottom, we click close pull request. Right, next, for a bit of hope in these sad times of failed deploys, we will have a successful deploy. In this section, we will introduce a normal update. So what we'll do here, same, we go to the dev branch again. It's common practice for any changes to originate in a sort of dev branch. They can have various names, but in our case, we just have one, so we called it dev. We start by changing the firewall rule back to something that worked in securitygroups.tf. And then we update something in user data. So let's do the first bit for now. Again, step 1, we make sure we're on the dev branch. We go to security groups. We edit them, and we revert that breaking change we had before, which was luckily caught by our pipeline. And now we, again, making sure we're still on the dev branch. We also edit the file userdata.sh.template. So this is a very short script that gets injected to our instance. And what it does, it's a bash script. First, it does some operating system updates, and then it installs Docker. It starts Docker, and then it runs a Docker container. In this case, Black Icebird 2048 Docker container, and it runs that. It listens on port 2048, which is why we add 2048 at the end of our URL. Thank you very much for Black Icebird, whoever they are, for providing this very useful Docker image. But it's time for a newer and better version. So we're going to replace this with a Pokemon version of 2048. So this is hosted on my own Docker Hub account. So we also commit this change directly to the dev branch. I'll leave it up here for a second if people want to make sure that they are typing stuff in correctly. And then we commit these changes to the dev branch. What does it say after that? Yeah, then after that we go to pull requests again. Oh, I've zoomed in so much I'm getting the mobile view. Yeah. And we create a new pull request. This will go from dev to staging, and then from staging to production. Again, very important to select our own repo, otherwise nothing but trouble ahead. And then into staging, from dev we go. We create the pull request. What checks should be launched when we do this? Yeah, which ones? Just the Terraform one, because the other one is only triggered on a master branch pull request. So it says here some checks haven't completed yet, so we wait for this. We don't have to, by the way. We are able to click merge pull request. This can be tweaked in GitHub settings. Ah, there we are. They've all passed. So now I can, with a reasonable amount of confidence, yet no man hours spent on this, merge this pull request. So that's merged. And now we create a second pull request. Again, making sure that we don't do any of the forking stuff. Sounds like I'm in a good place. Any of that forking stuff. And we do a pull request from staging into master. Create this pull request. Which health checks are we going to see this time? Indeed, we should see both. So it says some health checks haven't completed yet. They will also appear after a bit of a timeout. So the UI is not 100% reliable, but after some time, we should see that the 2 or 3 checks are there. This one was green already, so I'm wondering if GitHub just chooses this one because it was pertinent for the code before. And this one should have been green. So it's exactly because of that. Yes. Yes, indeed.
What do you do in this case?
You do an insignificant change and you merge that in again, which is yeah. Correct. So if you're a bit behind, that's good. Please pause. The problem here, indeed, is that because we've put our first pull request in, Terraform is now applying this to our staging environment, which means the staging environment is not yet up and running. And because I was too hasty, is it hasty? Is it hasty? Hasty. I was too hasty, and I've put the new pull request in already. The health check failed because the staging environment isn't there. So if you have merged into staging, wait a minute there until you can actually see your staging environment in your browser, because until then we can't merge into master. If anything, this shows that the health checks are more reliable than I am, because I thought it would succeed, but actually it doesn't yet. So it's a good thing we have them.
Once the staging is applied, you can rerun the actions by clicking the rerun button on the top right.
Oh, that's a thing?
Yeah.
I knew that.
So go actions on the checks page.
Here?
No. Go on the checks page wherever the result is in the actions. Yeah. So that's click on details on the failing one and B, and then top right corner rerun jobs.
Oh, indeed. Well, I'll wait until it's actually there. Again, once it's deployed, it's wise to wait another minute or so for the DNS record to propagate. Actually, no, that hasn't changed. But yeah, so now we see that staging has been applied successfully. Should have waited for that. And here we can see it. For some reason, I am not a front-ender, so I refuse to look into this. But for some reason, it can sometimes take up to a minute for any Pokemon to appear, just like in real life. So now that this is workable, if you had the same issue as me, you can hit Rerun Jobs. going to create a new pull request. If anyone is having issues at this stage, do raise your hand and we'll come by and try and help you. Going a tiny bit off-road here. You know it's a live demo because it fails. So it runs locally, so hopefully it should. It's running it again. All right, so we ran it again, so we can see that the same one here has succeeded that had failed before. I'm going to count that as a win. And now we can merge this pull request. What happens when we merge this pull request? What's the consequence of this? Someone needs to speak up. Fraud will also have Pokemons, I like that. So if we go to Terraform Cloud in our workspaces, we should now see, very shortly anyway, hold on, have I merged this? Oh, I haven't confirmed merge yet. The button wasn't green, so I didn't click it. So this was merged. So now, as a result, I didn't even need to refresh. Terraform Cloud started planning this, and because we have this set to auto-apply or auto-approve, it will start deploying this in a minute. And then the result should be what we have here. This should have Pokemon. That can sometimes take up to a few minutes. I don't do anything front end. Don't let that put you off. We have very competent front enders in house. So if your project involves front end, just make sure I'm not on it, and you're still good to go. All I know is that you can open inspect, and then you can hold this down and do empty cache and hard reload. And there we are. We've got Weedles. We've got Pidgeys. We've got potential copyright infringement. We've got Zubats and Magikarps. I only know the names in German. I had to learn them in English to talk to my girlfriend about Pokemon. There we are. That's the end of the playground. I'd like to take a moment to say thank you to all the fantastic team that have battled overheating projectors and handcrafted the little snippets of paper to hand out and all that. Please give them a round of applause. Again, thank you to Black Iceberg for the Docker image, and Schrader for the Pokemon version of 2048. And again, you have my email address. Please stay and have some pizza and some beer or soft drinks. And that's basically it. I hope you enjoyed it. And now give me a round of applause.